Good morning, good evening, good afternoon, wherever you are. Welcome to Summit Part 2, Summit Labs July edition. This is the Building Kubernetes Operators with Ansible workshop. I am Chris Short, Principal Technical Marketing Manager at OpenShift. I am joined today by my fellow Red Hatters, Michael Rivnak, Matt Dorn, and the wonderful Melvin Hillsman will be lab assistant today. If you have questions, please feel free to drop them in the Q&A box. We can use that to better manage questions and get you answers. There is also a chat. Feel free to chat amongst yourselves. If you have a question, it's going to be hard for us to monitor that chat and the Q&A, so try to use the Q&A box as much as possible. And we'll be running some polls during the event, kind of get familiarity with your familiarity with the technology we're talking about today, because every little bit helps making technology better. So your input really matters to us. So thank you again for joining us. We're super excited to have you here. Got a fun-filled evening or day, afternoon of activities for you all around building Kubernetes operators with Ansible. If you take nothing away from, actually before we get started, let me share this screen. These are support channels. If you take nothing away from this talk, here's some support channels that'll help you in the future. To kind of give you an idea of how the flow is going to go of the event, there'll be 4 modules presented by myself and Matt Dorn. I'm doing module 1. Matt is doing 2 and 3. Module 4 is me again. There'll be a short break, 15-minute break, intentionally at the 1 o'clock UTC spot. So we're going to go through slides for the first hour. And then we're going to come back after our break and do actual hands-on module or workshops with Katacoda modules. So yeah, we're excited, and I'm going to kick this thing off with this slide, which is the most important slide. It's where to get more help if you need it. Again, I'm Chris Short. Also, this is live streaming to the rest of the world. Hello, everybody. Out there on OpenShift TV land. If you want to shoot questions at me on Twitter later, feel free to @ChrisShortMe. The Ansible Operator SDK makes it easier to deploy and manage applications with native Ansible support. What does that mean? It may not make a lot of sense right now, but we're going to get some more familiarity with this as time goes on. Operators are usually written in Go, which is the main language Kubernetes uses. But you can actually use the Operator SDK to build operators with Ansible. Ansible fits naturally into a Kubernetes environment. And I say that because both bring joy to their users through automation orchestration, right? Like you can deploy your applications with Ansible, you can deploy your applications with Kubernetes. Both are very active and very widely used open source projects. I think last year in the GitHub Universe Index, they were like 7 and 8 or like 5 and 6 or something like that. So wildly popular projects, wildly vibrant communities. And guess what? They both use YAML to declare their states of the world. So YAML and Ansible, YAML and Kubernetes, you kind of know how to write both. You just need to get the syntax right. So at that point, you're learning syntax and not a whole language in and of itself. So yeah, those are kind of where my two, natural places for Ansible and Kubernetes where they fit in. A perfect example here is YAML to describe the desired state of the world in Kubernetes on the left. And in Ansible, you can use the K8s module to just do the exact same thing on the right, except you could say instead of color being red, it could actually be a Jinja2 variable that you can define elsewhere. So the K8s module allows you to use all the Jinja2 templating functionality, and that's not really something that's supported out of the box, templating with YAML. But Ansible allows you to do that. And how would you call something like this with, Ansible in a playbook itself? It's real easy. You can do your template lookups with a simple K8s definition and a lookup from your template itself. So that foo.yaml file that you create as your template is just looked up in the K8s module as a definition itself and applied. Apply to the clusters that you're managing. So it's a very graceful, way to kind of templatize and deploy Kubernetes manifests with Ansible is the best way to describe it. Now, is that super useful? Sometimes, sometimes it's not, right? Like that might not, this might not be your cup of tea right now, but there's something that we need to like make very clear. Stateless is easy. Stateful is hard. With Kubernetes, you get a lot of powerful functionality that makes it relatively easy to manage and scale apps, API services, everything you can think of, right? Deployments, replica sets, whole 9 yards. You can operators enter the picture, and you get this whole wealth of things that you can just install on your clusters. Off you go. You're off and running, and you have these fully baked applications potentially that are writing state, and they're very important to your business. And businesses are built on state, right? Like you don't have a business recovery plan. All right. If you don't, to not recover state, right? You're recovering the state of the business. If you have a business recovery plan that doesn't worry about the state of the existing business, then you're serverless and everything's great, right? No, I'm just kidding. So operators fit into the picture here because we need to manage a lot of things at once, right? Like just managing the Kubernetes bit is not enough. So Kubernetes operators come in here, pardon for the typo or misalignment here, but operators simplify the management of complex applications in Kubernetes. Think about it as a way to install, upgrade, manage, orchestrate, maybe uninstall or auto update itself. Like we want to, operators really kind of enable day two management with code or with Ansible playbooks in this instance. So we really like the idea of operators for everything. And you really see that in OpenShift 4. Operators manage the state of the actual cluster from instantiation all the way up to, your services are being deployed. Operators are behind the hood kind of managing all the APIs behind the scenes. They enable you to program Kubernetes with the smarts it needs to effectively manage your applications or services. So you don't necessarily have to intervene if something goes bump in the night. So you kind of bake your human operational knowledge into these operators, and they're purpose-built to handle errors or events or, get everything back to their declared state as you declared it in the operator. The operations, without operators are very reactive, right? Continual checks for anomalies, humans alert, responding to pager duty kind of things, manual changes to fix things. Like that's not a good state. Operators allow you to be a little bit more proactive. And boy, I really need to re-review these slides. I did not copy these well into our new template. Sorry. But essentially the operator pattern here is you have the Kubernetes API over on the left. You build a custom resource and your application state. That's what, you end up with once the operator is run. And that controller watches for events and creates a reconcile loop. And what that happens is your operator will watch for events based off of the group and version and kind that you've built it for. So if it sees a corresponding event for, Kafka, it's going to say, okay, wait, I should do something with this. Okay, what kind of event is it from Kafka? Oh, it's an ad. Okay, just let it go. This is a failure. Okay, what do I need to actually do? Reconcile. Okay, or we lost a listener. Reconcile it. Bring it back up. That's what the controller is doing for you. It's giving you it's watching for events. It's reconciling based off of the operational knowledge you have baked into this application, essentially this operator, to manage your Kubernetes application for you. That's the end state we want to get you to. The operator framework, super cool. So I didn't have time to plug this in today, but last week finally got it donated, the two left parts, the lifecycle manager and the operator SDK itself, donated to CNCF. So it's now in incubating status with CNCF. This is a big deal for us because that means the rest of the community can now jump on. It's never been a Red Hat only thing, right? Like you could run OLM on a, just clean vanilla Kubernetes cluster that you stood up off of the KK code base. And then you can bring in operator lifecycle manager there, and the operator SDK gives you all the fun capabilities to manage your operators on the cluster yourself. So the operator metering piece is another component that did not get donated to CNCF. It was not germane, right? It's for basically, measuring costs of services and things like that. So not too much. Oh, I hit the end button, and now we're going to go back through slides again. Oh, I love fat fingering things. Okay, so moving on. It's the idea of the Ansible operator SDK is making it easier to deploy and manage Kubernetes apps in an Ansible native way. So if you're very familiar with Ansible and not so familiar with Kubernetes, this can help you bridge the gap. So essentially, it's an operator SDK new command, just like you are making a Go operator. Instead, this time you're going to say a type of Ansible, and it's going to build out a scaffolding that allows you to apply your roles and your playbooks however you want for your life cycle of your containerized apps. And then you hit that operator SDK build command, and it uses the operator SDK and fires it off to your cluster. This is really cool and really powerful in the sense that you can have a quick scaffolding, throw in your existing role or playbook to do something with your application, assuming that it's been redesigned for your containerized environment, right? Like in a cohesive way where you can still interact with it with that playbook. And then you just hit build. So you go from, I've got this running on a VM in Ansible to potentially I've got this running in a container in Kubernetes with an operator to boot that handles all the state and reconciles that state every time something goes bump in the night. So that's kind of the natural fluidity. If your app is already using Ansible to deploy and orchestrate itself, you can, in theory, plug that straight into Kubernetes with the operator SDK. Now, will that be as clean and dry in all cases? No, but there's obviously some cases where it will be. So why build operators with Ansible, right? I think this is a very legitimate question. So it's the same tried and trusted Ansible tooling. Utilize the existing skill sets, like I mentioned, right? Like you don't have to relearn some new orchestration tool on top of Kubernetes, right? Like you already have some Ansible skills potentially. You add in your Kubernetes skills. They both use YAML. They both have vibrant ecosystems. It's a lower barrier of entry, right? Like Ansible's biggest claim to fame is that it has a low barrier of entry compared to other tools in its ecosystem, right? So it's not necessarily programming, but it is creating declarative states within K8s. And it'll also, using Ansible allows you to templatize your Kubernetes manifests, all your YAML resources, and it can be that abstraction layer, right? Like it can be the lens you see K8s through potentially, right? Or if you have to interact with multiple services, right? Like let's say, okay, you've got this thing running on your Kubernetes cluster, but then you have to touch some external service. You can make use of the existing Ansible modules to integrate with those like exterior services in a cloud, for example, right? Like if I'm in AWS and I want to use an external database, or Azure and I want to use their DNS, I can create an operator with Ansible that uses those existing modules in the Ansible libraries to do those operations. So yeah, like there's lots of potential here for success. And if that's not good enough for you, how about a cool logo? It's the operable. Operators with Ansible makes Kubernetes sing. Come on, that's a good logo. I like it. Anyways. All right, so we have what we call the operator capability level, right? And we throw Helm on here to kind of give people an example. Well, didn't an operator kind of like Helm? Kind of, yeah. Helm can do some basic installs and some upgrades. Ansible, you can do some basic installs, some upgrades. Actually, manage the backup and failure recovery of your applications. You can get metrics from it and logging and alerting, and as well as kind of scaling. Is that phase 5, that autopilot is what we call it in operatorhub.io. If you go to autopilot, you can see like those full-fledged, like they're designed to just run themselves. We'll interact with them as you need, but otherwise they're always there keeping the lights on for you. So with Ansible and Go, you can create these, phase 5, fully fledged operators. With Helm, they're just not quite there yet. right? The Helm community has come a long way, but we're not quite to the point where, we're taking operators and doing full autopilot operators with them. There are quite a few Helm-based operators out there, but again, they can do upgrades. They're not going to help you with recoveries and backups and the deep insights you would expect from modern day applications, as well as the scheduling, tuning, horizontal scaling, vertical scaling, anything like that you would need. You're not going to get that from a Helm based operator. So that's why we kind of push Go and Ansible. And that's why we're talking about Ansible operators here, because it does give you that phase 5 autopilot kind of capability. So I hit you with this a minute ago. Now let's actually throw in your playbook or role into the picture, right? So instead of that controller with your operational code and everything, the watch file is still there, the reconcile loop is still there. That watch file, you actually define the group version kind that you're looking for. Then you have this operator SDK binary, which essentially is that go-between between Ansible and operator SDK to Kubernetes, right? So it allows you to take that playbook, dump it in here, and then deploy that thing, ship it off. So it's actually a very, very nice, tightly packed binary. It includes a thing called Ansible Runner, and that allows it to just run nice and neatly inside your cluster without a lot of overhead. Now, if you go back to the capability level, like what's faster? Go is obviously the fastest, like it's the native language that most of the stuff in Kubernetes land is written in. And Ansible and Helm do have kind of, there is an abstraction layer there that you have to consider as far as speed goes. So keep that in mind. If you're doing something with storage, probably want to write it in Go. If you're doing something with external services or networking or something like that, Ansible's a very good choice. So deploying your first Kubernetes operator with Ansible, let's walk through this. It's slideware. It's not a demo. I'll do a demo later. But so you develop or you reuse your Ansible content to reconcile Kubernetes applications. Typically, your automation will leverage the Ansible K8s module. So you want to be highly familiar with that module and its associated modules to interact with the Kubernetes cluster itself. And then you can use other Ansible modules as you see fit inside or outside the cluster. So if you had the operator SDK installed, super easy to install. If you're on a Mac, it's brew install operator SDK. If you're on Linux, it's pretty much your package name, operator SDK install kind of deal. So yeah, you would set up your first Ansible operator in the way of what, in this case, we're building a memcached operator. So operator SDK new, memcached operator is the name. The API version, we create this, right? So we'll call it cache.example.com/v1alpha1. And the kind, we'll call it memcached. And then the type, very important, Ansible. And that will, when you hit enter on that, it will build a skeleton for you with a watches YAML file, a CRD, deploy manifest for the operator, and some basic tests for Molecule. Molecule is a testing platform that Ansible adopted a couple of years ago, or Ansible brought into the community a couple of years ago. Super great addition to the Ansible repertoire of tools. It's great that we now have a way to unit test Ansible files, and now you can actually unit test your operators with Molecule. So that's very, very nice. So that initializes your operator, and that gives you that scaffold right there on your local machine. What does that look like? If you run the tree command, this kind of scrolls over to the next side of the slide there. So it actually gives you quite a bit of files, but there's really only a couple that you actually touch in here, which is kind of cool. Obviously, that requirements.yaml file, if you have any prerequisites, like you're pulling some role in from Ansible Galaxy before you do anything, stick it there. Your role itself goes in that roles directory. And that roles directory is scaffolded out for you in a very similar way that you would get from like an Ansible Galaxy. And then you have the Molecule test directories, that watches file, vitally important, and the Docker file and the deploy CRDs directory, that CRD in there. Those are really the main files you're going to touch as far as the operator goes, are the watches, Docker file, maybe, and the CRD for sure. So let's take a peek at that Docker file, right? So the Docker file is pulling an image from Quay, the actual Ansible operator. It will pull in your requirements.yaml, whatever they may be. It'll run Ansible Galaxy Collection install and get all those set up, and then copy the watches file in, and then copy the role in. So that's all going to be running in your container. That container is essentially the logic bomb that's going to, trigger on everything that happens event-wise on that group version and kind. I keep saying group version kind. Let's talk about that for a second. When you map Kubernetes events to Ansible automation, there's that GVK involved. That watches file actually contains the version, the group, kind, and the role that you'll be using to execute the associated Ansible content when an event does occur. So I keep saying events. When I say events, I mean Kubernetes events. So if you've ever watched a Kubernetes events file or events log just fly by, this thing's watching for anything matching, anything in that watches file, and then it will trigger as soon as it finds a match and run whatever logic you have decided needs to be run based off that event from Kubernetes. Pretty slick stuff. So the custom resource spec, this is the CRD file I mentioned. The spec is the values that are translated into extra vars from Ansible. So if you wanted to give, some additional variables based off the environment, or you could templatize this for, dev stage prod kind of thing. You could do all that in here. And then the status will have generic status recorded by the Ansible operator itself. This uses the Ansible runner output, which is that Ansible output you're all familiar with, to generate meaningful and useful information for you. So essentially, it's the output of the Ansible playbook or role running. And that is what gives you the information that this has been either, a success, a failure, what has occurred, that kind of thing. So when you actually run operator SDK build, this is kind of what rolls out. It builds the image, pulls everything in. If you're running Docker, it builds it all for you, copies all the files in, and then operator build complete. And then you hit kubectl apply r-f deploy for, recursive deploy of all the files that need to get sent out. And it creates an RBAC and service account objects for the operator itself, creates that custom resource definition, deploys the operator to the cluster, creates a CR to initialize the operator, and executes basic molecule tests as needed, as you've programmed them. So with essentially 3 or 4 commands and a little bit of configuration throwing in a role or a playbook, you've got yourself a full-fledged operator here, and it's deployed to your cluster essentially. And it's been unit tested. So that's kind of the intro here. That's my spiel. There's tons of operators available at operatorhub.io. You can get those right now, today, tomorrow, when you're back at your desk, whatever, next week. And next up, thank you, first of all, and next up, it'll be Matt Dorn with Module 2. Matt, you're on ready?
Yeah, I'm here. Thanks, Chris, and thank you for that great introduction. I appreciate it. Hi, everyone. My name is Matt Dorn. I am a principal engineer here at Red Hat, and I'm going to do a little bit of a deeper dive into what an operator is. So Chris did a fantastic job going over the Ansible operator, and we're going to take a deeper dive into that as we progress. It's totally possible that some of you that are fresh and new to all this stuff still may be a little confused as to what an operator is, and that's okay. We're going to talk about that here. So let me go ahead and share out my screen. 1 second here. Okay.
There we are.
So what is an operator? If you go look up the formal definition of what an operator is, you'll see that it says an operator represents human operational knowledge in software to reliably manage an application. But what does that really mean? What are we talking about here? Well, if you run this command, OC get operators, just let's say you just run this command just to see if there's a thing called an operator. going to come back and say the server doesn't have a resource type called operators. So right off the bat, what we have to understand is operator is really just a nickname. And to really understand where that nickname originated, we have to go back a few years. So let's go back to November 2016. This is on the CoreOS blog. For those of you that are not familiar with CoreOS, CoreOS was a startup based out of San Francisco here in the US. They specialized in something called Container Linux. Container Linux was an operating system that's sole goal was really just to run container workloads. Didn't have a package manager installed on there. It had auto updates enabled by default. It was just there to run container workloads. And during this time, Kubernetes started getting very, very popular. And so the folks at CoreOS started to invest time in building their own Kubernetes distribution and running Kubernetes on CoreOS. Now, Red Hat acquired CoreOS 2 years back, and a lot of those features found in Container Linux are now featured in RHCOS, which is really the operating system that powers OpenShift. Of course, you can run OpenShift on regular Red Hat that you know and love, Red Hat server. But RHCOS, or Red Hat CoreOS, is the primary operating system that you run OpenShift on. And within this, in this blog post, Brandon Phillips, CTO of CoreOS, says, we're introducing this new thing called operators. What is it? Well, it's three things, right? The operator kind of takes on the responsibility, just like Chris said, all that manual work, stuff that you would do if you were a site reliability engineer, all that manual work, all that stuff getting paged in the middle of the night, you're putting it into an application, right? And you're putting it into an application that resides on Kubernetes. So an operator is a nickname for a special Kubernetes application, right? And this application, first of all, utilizes a resource. We're going to learn what a resource is, but not just any resource, a custom resource in Kubernetes. It utilizes a controller. And for those of you that don't know what controllers are in Kubernetes, these things run at all hours of the day, 24/7. They power your Kubernetes cluster, right? And we're going to learn what controllers are coming up. And then we have application-specific knowledge. Application-specific knowledge. This is sort of all of that knowledge that only you know about your application that you're going to codify and put into your program, put into your operator or into your controller. So let's go ahead and explore these: the resource, the controller, and the knowledge, which make up an operator. First of all, resources. So we know that out of the box with Kubernetes, you have these things called resources. Pod, the fundamental unit of Kubernetes. A pod can contain one container or multiple containers. And we know containers in that pod typically share the same host name. They share the same interprocess communication. They share the same network stack, right? Like, so if you do like IPA or ifconfig, you're going to see these same IP addresses in all the containers you run in one particular pod, right? That's the fundamental unit we're using to deploy our application. Then we have something called a config map. You all know config maps if you use Kubernetes day in, day out. That's where you put your application-centric information. You can bind your config map to your pod. That's how your binary or your program, your application, whatever's running in your pod is going to consume configuration information. And then we also have the route. The route, some people that use Kubernetes are like, what is a route again? Route's like ingress in the vanilla Kubernetes world, right? Route is an OpenShift API term, but the concept is the same as ingress. It's a way to give your users access to an application that resides in your cluster, okay? These are all resources. You're going to learn that an operator takes advantage of something called a custom resource, which we're going to learn about coming up. What are controllers? Well, controllers run all inside Kubernetes 24/7. They never stop. They really are the powerhouse. What are controllers? Well, things like this, the replica set. The replica set is a controller that we're going to take a deeper dive talking about because it's a great controller to study, to understand that pattern that Chris was just talking about. That operator pattern, really, you can understand it just by looking at the controllers you get out of the box with Kubernetes. The replica set, you specify how many pods you want, and it ensures that many pods are running. Why do we need multiple pods running? Because 2 is 1 and 1 is none. We all know that if we have one pod running, our application goes down, that's going to be an outage, right? So replica sets allow us to run multiple copies of our application. Another example of a controller is the daemon set. The daemon set, for those of you who don't know, is a way to get a pod to run on every single node in the environment. And that node may be a virtual machine, it may be a bare metal server, whatever it may be, right? But it's running on every single node in the environment, that this pod. And if one of those nodes goes down, those VMs go down. Let's imagine the bare metal server is unplugged, right? And when we go plug in a new one, or we go ensure that your VM spins back up, it's going to ensure that that workload is running on that brand new node. So the daemon set's a controller that's always running to ensure that a pod is running on every node in the environment. And then, of course, we have deployments. For those of you that don't know what deployments are, before deployments came along, doing rollouts from, let's say, version 1 of our replica set to version 2 of our replica set was a hassle. It was all client-side calls. You had to manually go spin up a new replica set. You had to slowly eliminate old copies of the old version. It was a real hassle. Deployments do that rollout for us, all server side. They allow us to roll back. They also take care of our replica sets for us, right? So the deployment controller is really, really awesome. And then we have domain or application-specific knowledge, right? Remember what Chris said in the beginning of this introduction. Chris said, stateless is easy. What do we mean by stateless is easy? Kubernetes was originally built for stateless applications, right? Think about that really cool party trick that you do when you show people, here's a replica set. I'm going to delete a pod. Look how quickly it respawns a pod. Everyone loves doing that, right? It's a magical feature. Well, the reality is that, think about it. The application that you're running inside that replica set is most likely not storing any state, right? But state is all stored on the client side, or perhaps you're just using some local cache on the host. You're not using a persistent volume. The concept here is that these are for apps that come and go and are not really relying on any particular data that persists anywhere. So when we talk about domain or application-specific knowledge, we're talking about that you have probably a stateful application that only you know about. So not only do you want to be able to install it, but you want to be able to scale it properly. What I mean by that is when you think about in Kubernetes, the replica set, it just blindly has no cadence or rhythm to the way it just like spins up a new pod. That's fine for stateless applications, but not for your database application that has to come up in a particular order, that has to talk to its peers to check in and get help information. Only you know the way that your application, your stateful application should scale. Therefore, you would program or put your code in to specify how to scale. This is something you put into your operator. What else? Things like self-healing, just like Chris mentioned, getting that call in the middle of the night. It should be able to resolve itself. You should have the necessary checks in place, and there are many ways to implement this. Cleaning up, right? When you're done using the operator or application. How about updating when you want to go from version 1 to version 2 of your application, right? What about backing up? You can't rely on backups stored in the cluster, because what if the cluster goes down? You need offsite backups, right? And of course, if you're doing offsite backups, we have to be able to restore those backups in the worst case scenario, right? This is the kind of human operational knowledge that we're talking about here. So an operator takes advantage of what Kubernetes does best. If you run this command, kubectl proxy, maybe some of you have run this command before. This sets up a proxy to the API server where you don't have to send your authentication credentials every single time. Can you imagine what a hassle that would be every time you wanted to actually go and use the API and explore the API? Because the Kubernetes API really is the unsung hero of the Kubernetes platform. I mean, it's amazing the way you interact with it, the watch features, which we're going to talk about coming up here. I mean, it's well structured. So how do we talk to it without having to give it credential information? Set up a local proxy, which authenticates us with our kubeconfig file, and then we can just hit it with the localhost 8001. So let's imagine, hypothetically, that we have a cluster here, and we're hitting it via localhost 8001. Well, guess what? As we start hitting it, what happens is we get to see all these resources that appear on the API. And guess what? There's a complete correlation between the resources that you see when you run, for example, kubectl get config maps or kubectl get endpoints. You are essentially sending API calls. What sort of API calls are you sending when you do this? You're sending RESTful calls, right? You all know RESTful calls, things like put, post, get, delete, head, things to actually go and, check the availability or to write a new object to that API. The client, the kubectl client, is just sending API calls. And that's not just the kubectl client. That's how anything that interacts with Kubernetes does it, right? Even the client libraries, which we're going to talk about coming up. So for example, if we say kubectl get pod, and here we're getting the actual kubedns pod, and we're saying, please show us what's inside this kubedns pod. I want to see the details inside the kube system namespace. Show me that YAML object. It's just doing a get behind the scenes against this API endpoint, okay? And after we do that, we get back this object, which we can go then and explore, right? Remember, Chris talked about the GVK. In this case, the version here, we don't have a group, we just have the version 1. And then here, it's the pod, right? This is a representation of a pod. And for those of you who don't know what DNS pod is, DNS is what allows us to do service discovery within our Kubernetes cluster. So operators take advantage of custom resource definitions. These were formerly known as third-party resources, but these are the key to understanding operators. It's really a very, very powerful feature, custom resource definition, because what custom resource definitions really allow you to do is create your very own API endpoint without having to pull the actual source API code down, adding a new custom type or struct, and then recompiling and then republishing. Literally, you can have a running Kubernetes API server and send an API call to actually build out a new piece of the API. Kind of blows your mind a little bit, right? So CRDs, or custom resource definitions, really allow us to extend the Kubernetes API. Let's go ahead and extend the Kubernetes API by creating our very own object or resource via CRD. So we're going to actually show you what this process is like, and it's pretty easy. First of all, before you actually do this, you have to have some very, very good privileges, right? Because if you think about it, you're actually going and extending the API. So you really have to understand that to do something like this, you need cluster-wide permissions, because the API is cluster-wide, right? Everyone can see it. It's like the sky, that we see. It's the entire cluster. So here we go and we create a new custom resource definition. Notice that it's just kind custom resource definition. This is the group version, like Chris talked about. And here we're creating a brand new type called MySQL. That's just the name of it. This isn't necessarily suggesting that we're going to create a MySQL pod or anything like that. It's just a new API endpoint called MySQL. Now you can probably imagine what we're starting to build with this, but it's just a new API endpoint called MySQL, okay? Now after we create that custom resource definition, right, we can then run this command, kubectl get CRD. And what happens after we run this command is we actually see that the custom resource definition was created. So at least we know that, it worked. It worked. After we actually run this command, localhost, we run our localhost, so we have our proxy running. And you can see that just via the API, we have this custom resource definition created. Now here's where things get interesting. We can now verify that our API server responds to the word MySQL. What do I mean by that? Well, if I run this command, kubectl get MySQL, which never existed before this, I'll get a response back that says no resources found. Now that seems a little sad. It almost seems like something's broken here when you see that, but there's not. This is actually a good thing. This tells me that there's an API endpoint called MySQL, but we just haven't created a MySQL object yet. We've just created, think of it as maybe a class, something like that, right? There's just not an object created yet. So how do we verify this? Well, first of all, check this out. Notice that now I can run a RESTful get verb against my API endpoint, and I can actually say namespaces default MySQLs. Do you see that? Notice how now I have that MySQLs endpoint. Pretty cool that I created that just by running that command a couple slides back. Now, obviously, I don't have any objects created yet because I have a nil list of items, but the fact that the API endpoint's there is pretty cool. So how do we create a new MySQL object? Basically, we're going to create something like this. It's going to use kind MySQL because that's what we specified in our custom resource definition. And it's going to use this group version that we also created. And the group is really important, right? Because you can imagine multiple companies, multiple people, who knows, may go and develop multiple MySQL custom resources. This is a way to disambiguate various companies or people that may develop similar custom resources. So you can just tag it with your website or what have you. And then we're going to be calling it WordPress, because obviously we may be creating this thing for WordPress. And then here in the spec section, that's our declaration. That's where we're saying what we want. And for those of you that know what WordPress is and know maybe what a MySQL database, you know that we want to create a username and password for our WordPress, which uses MySQL as the backend. So we're putting in some information, our declaration, into the object, things we want. Now, a whole bunch of questions may come up here where you're probably thinking like, well, how did the user know to put this information in? How do they even, understand? Is there a man page? Or, well, with the custom resource definitions, you can actually create your very own explain information. For those of you who know the command kubectl explain, there are a variety of ways to put validation information here to enforce particular types, like only allow a person to put a string here, or an integer here, or a Boolean here, etc. There's a bunch of ways to do that, and we have a lot of good stuff like that in the documentation. But for right now, let's go ahead and create this object. After we go and we create the MySQL object, we're going to go ahead and verify that the object exists on the CLI. Notice now, when I do go and I run kubectl get MySQL, it comes back and it says WordPress. So it obviously created something. And if I do -o YAML, it now tells me, hey, by the way, here's your object you created. And of course, we have some extra stuff that was put in here for us. We all know that there are various controllers, various processes that are running in Kubernetes that are going to add this additional information for us after it persists in etcd. But here's the reality. Here's the big secret that a lot of people forget to tell you. Just because I created something on the API doesn't mean that now that thing exists in my cluster, right? Think about it. All you did was change the API. You didn't do anything to your cluster. That's because a custom resource, and really any resource, needs a controller to act upon its presence, right? Think of the source of truth, right, really is that API server, but we need something running in our cluster to look at that API server and say, that's what I need to do. So this is where the controller aspect comes in. And Kubernetes controllers, again, are always running in your cluster 24/7. What do? Well, first of all, they are programs that have been built to watch the current state of the cluster. And they use this watch program. They're calling a watch program on the API to say, I want to pay attention to these objects. And please send me an event when there's a create event, an update event, or a delete event. So in other words, if I'm watching for kind MySQL, if kind MySQL is created, if it's modified or edited, or if it's deleted, send me a signal. Send the controller a signal. Once the controller gets that signal, it's going to analyze. It's going to compare the current state of the cluster, how things currently exist, to the desired state. What's the desired state? The desired state is that spec section that we showed you inside the object. That's always the declaration. That's what a user wants. That's why Kubernetes is declarative. You tell it what you want, it makes it happen. In our case, it was that MySQL WordPress with the username and password, right? And then it acts. It compares what currently is to what we have to do, and it makes all the actions necessary to make the current state meet the desired state. We're going to take a deeper dive into how this pattern actually works just coming up, but understand that this is really the key to your business logic. This is the key to your human operational knowledge. So we understand controllers by studying the embedded controller built into Kubernetes. This is a great little exercise to understand how controllers work. Just look at the replica set. You all know how the replica sets work. Well, what do? For those of you that aren't familiar with them, they help with redundancy. That means running multiple instances means failure can be tolerated. So we all know that if you're running multiple pods and one goes down, Kubernetes gladly spins up a new one, right? That's the great thing about replica sets. That controller is constantly watching to ensure a new one gets spun up. Why else is it important? Well, think about when your application gets very, very popular. We have something called a horizontal pod autoscaler, which observes a particular CPU average threshold. And then once it hits that threshold, it's going to go create additional pods, right? And then sharding, because multiple running instances can handle different parts of a computation in parallel. So think about when you want to like convert a movie file or something, or convert some file, just spin up some more pods to assist you with getting the job done faster. Batch processing, if you will. So how do replica sets work? Well, you create one using your Kubernetes object manifest, right? And notice how you're declaring that you want one pod. Well, it will go and create one pod. Now notice how it's using the selector to keep track of your pod. In fact, labels and selectors, and think about, people always ask, they're like, what's the difference between a label and a selector? A selector is nothing more than specifying which labels you want to look at or filter. That's how replica sets keep track of their stuff. They keep track of their stuff by using labels. And if we go and change, think about this. If we go and change the number of replicas, in this case to 3, as you can see we've done here, the reality is that the replica set controller just received an update event. It just received a notification that you need to go ahead and trigger your what we call the reconciler. The reconciler then gets triggered, and what it does is it looks at the actual state, and you all can actually see the actual state in the environment right now. You can see the actual state is that there's one pod, and it compares that to the declared state. Notice the declared state right now, 3. So it says, okay, I have one pod. This wants me to have 3. There's some logic inside your reconciler, which says, if that's the case, if I have less than what's specified, go ahead and make it so, and it will spin up more pods. So in this case, the replica set is a controller that is running, right, and watching for replica set or kind replica set resources. And the things it creates are the secondary resources. And these secondary resources typically have something called an owner reference on them that ensure that when I go and delete the replica set, the pods get cleaned up as well, so they don't have to do that manually. Okay? And we have the replica set control loop. The replica set control loop basically consists of what we just showed you. Finding pods matching the label selector, compare the match versus desired pod count. If there's too few, create additional pods. If there's too many, delete the excess pods, right? Just like we explained. And this thing gets triggered anytime there's a create, update, or delete event. So, great book, check it out. Cloud Native Infrastructure by Justin Garrison and Chris Nova talks about this concept of the reconciler pattern. Software pattern that can be used or expanded upon for managing cloud native infrastructure. It will force the engineer to have 2 avenues for getting either of these representations, as well as to implement a solution to reconcile the actual state and the expected state. Again, that idea of what is and what's being declared. So here's another view of how a controller works, right? The controller watches for replica sets and watches for pods, and not just any old pods. We're not going to have it watch for every single pod inside of a namespace. We're going to say only watch for pods that are owned by this particular replica set, right? Because you can imagine people are going to spin up tons of replica sets in one namespace. So this only pays attention to pods that have a particular owner reference for this replica set, right? So for example, I go and I spin up a replica set. It creates an event that the controller sees, and the controller is going to run its reconciler, and it's going to get the actual state by listing all pods that have the label. In this case, my first app. We have no pods created yet, so we know that 0 is less than 3. So what we're going to do is we're going to create a pod. The very creation of that pod owned by this replica set creates another event that my controller sees. My controller gets triggered again. It does an audit, or I call it the audit. I use the word audit, same thing as actual state. Now we have 1, but that's still less than 3. So then we go and create another. Another event gets triggered. Now we have 2 is less than the number of replicas. We go and create. Now we have 3. I won at 3, and we're happy. Do you see that? But look what happens if I go and I delete a pod. That's going to trigger another event. It's going to cause me to do another analysis, comparison. I'll create another pod, and then I'm happy. These controllers are constantly reconciling. They're constantly running, and you can watch their logs in real time. Deployments. Another controller that right when you create a deployment, the deployment controller will go and create a replica set. The really cool thing about this is, guess what? This is actually 2 controllers. The deployment controller makes sure the deployment's always running. The replica set controller will ensure that the pods for that replica set are always running. So you have two controllers kind of working together to ensure that everything's running properly. Just like this. Do you see that? So they're working together to ensure this. So we create our MySQL object just like this. And what happens when we create our MySQL object? We have to have our controller running in the cluster. Our controller running in the cluster sees the API server, right? And then what does it do? It's going to go and create a MySQL pod. But listen, it's not that simple. It's not just like we're going to create MySQL database. You all know that have been MySQL admins before. Probably not enough just to create a MySQL database. Think about all the tasks that you need to do when you manage MySQL. Even traditional MySQL, even if it's not in a container, just in general, tons of stuff, right? This is all the human operational knowledge you're going to put into your operator, all this stuff, okay? So to recap, custom resource definitions plus custom controllers plus your knowledge equals to operators. Why do they matter? We're trying to give an as-a-service platform experience. We're trying to build an ecosystem of software on Kubernetes that is easy and safe and reliable to use and operate as a cloud service. Low touch, remotely managed, one-click updates, kind of giving you that cloud experience, right? Like when you're on AWS, you want to spin up, you want to go and spin up a relational database. You just fill out a form, it's running. That's the experience you want to be able to have on OpenShift, for example, on Kubernetes, right? And you can imagine on the dashboard, you just go, if you want to run one of these operators, just click enable and it starts running, okay? Really creating an operator is just a matter of having a custom resource definition, okay? And then deploying the actual operator, which we use a deployment as the vehicle here, that has the controller binary in it. And then we create our actual custom resource and the operator is running, just like that. And thanks to the operator lifecycle manager that Chris talked about, that was donated to the CNCF, was it last week? You can install OLM. It does all this work for you, which think about this. Remember I told you that in order a custom resource definition is a very privileged action to create that. You can have a regular user who's just an admin within an individual project, and you can give them the ability to install an operator. Really, really powerful stuff, right? They don't have to even have cluster admin privileges. It's really, really neat. So then obviously the operator is running and we create our object, our etcd cluster. This is a cluster on top of Kubernetes. And guess what happens? Our cluster is running. And this is probably, if we were to do an OC or kubectl get pods here, we would probably see 3 pods running that have come up in the proper human operational way, right? So how do you create your own operator? How do you create your own operator? We are going to explore that coming up here, but just a few little things here just to understand. If only really it were as simple as just defining what resources we want to watch and just writing some pseudocode here, like get the desired state, compare it to the current state, and just make it so. It was very, very complicated for many, many years because custom operators require all these building blocks in boilerplate code, right? A lot of pieces. First of all, you have to research and download tools to interact with the API. These are the Kubernetes client libraries like Client Go or the Python client. These are ways to programmatically interact with the Kubernetes cluster with a programming language of your choice. You have to have a knowledge of informers and shared informers for object cache and event handling, because think about this. You have to have caching because you have all these controllers running in your cluster, right? Can you imagine how taxing that would be on the API if you just have all these controllers that are constantly hitting the API without utilizing a cache layer for performance? Communicating desired state and actual state via annotations. You used to have to track Kubernetes resources manually, test scaffolding and repo organization. This is just an example of an operator project that used Client Go directly, okay? And we needed an easier way to create operators and needed an easier way to manage operators. So that's where the operator framework comes in. The operator framework is a series of tools, the operator SDK, the operator lifecycle manager, operator metering, ways to make operator life easier. With operator SDK, just like Chris explained, you can build an operator in 3 ways. First is via Golang. You may be thinking, that doesn't seem very easy. I don't know Go that well. Compared to building one from scratch, all you have to do is focus on your business logic and Go. That's it, right? So if you know a little bit of Golang, you probably make something pretty cool. Ansible, we're going to do a deep dive into this and do some exercises. This is where you actually associate your custom resource definition with an Ansible playbook or role or collection. Very, very powerful because if you're already comfortable writing tasks in Ansible and you already use a variety of modules in Ansible, you can use all that stuff to build your very own operator. And of course, we have the Helm-based operator. Helm-based operator is a pretty cool way to take an existing Helm chart and just easily run like 2 commands and have that thing in an operator format, if you will. Operator Lifecycle Manager, we told you before, enables cluster admins to manage operators on any Kubernetes cluster, and most importantly, allows a user that may not have cluster-wide privileges to deploy an operator. And then operator metering for recording historical cluster usage and generating usage reports. Check out operatorhub.io to explore operators. It runs on any Kubernetes cluster. It also comes, an embedded operator hub also comes automatically on OpenShift 4. You can check that out at try.openshift.com. And I'll go ahead and send it over to you, Chris.
Thank you, sir. I am getting my video turned back on here. I believe you are actually, was that both of your modules all at once?
Yes.
Awesome. Great. What I was afraid of. So, folks, I have some sad news. I accidentally blew up my Kubernetes cluster. You might have heard this one before. So the demo that I was about to give for a running operator, sadly, I have no demo to give you now. So I am hoping.
I'm happy to. I have one running.
You got one running? Can you see me?
Yeah.
Can you see me the creds for it real quick?
Sure. Yeah.
Yeah, that'd be great. Perfect. I'm gonna really mess it up though. Apparently.
No problem. Let me grab this for you.
Yeah, let me share my screen real quick. Sorry, folks. I had it ready. It was all set and ready, but I wanted to tweak one thing, and you know, that's life sometimes, I guess. Yeah.
Do you want CLI access, or give you this UI?
Just the console. Just UI. CI.
Okay. Cool.
Or the console. Thank you.
Sure.
That screen shared there. Operators in the wild. So really, this is going to be a demo exercise of installing an operator. Kind of show you how easy it is to get going and you know, maintain operations with them. We've been running some polls, if you haven't noticed, just kind of gauge interest level and overall, you know, capabilities that the people in the room have. Matt's trying to type to me right now as I'm trying to hastily, you know, get a cluster together here. Hope that, yeah, it's the moderator only chat. I did not get the URL, Matt. You know, I want to send it over Slack. So if you could please answer the polls. We've got 2 here. How much, you know, where are you on your Kubernetes journey? Surprisingly, first time I've seen it since we've been running this workshop. Everybody on here that has answered has experience. So that's good to know. That's very good to hear. And we're asking, you know, how familiar are you with your, you know, with the Kubernetes or with operators and the operator pattern? A lot of people say that this workshop is their first experience. So don't feel bad if that's your answer. It's totally normal answer. Let's see. Matt, where are you?
One second. I'm grabbing the URL. Sorry.
Okay, cool. No worries. Take your time. I can tap dance here for a little bit longer. So if, you know, we have, you know, Michael Rivnak is here. He'll be up after this quick little demonstration. And, you know, he is somebody that taught me about containers way back in the day. He's one of the first people, him and Vincent Batts were one of the first people to introduce me to containers. And so, and Matt, you know, has been part of this, you know, Ansible operator team since the beginning, is a wonderful engineer. We're super, you know, fortunate to have him with us here tonight or today if you're, you know, in the daytime time zones right now. So, you know, if you do have questions about Ansible operators, Kubernetes in general, like, fire away. So we've got some real good experts here. Watch, Matt. I'm gonna get an email that my thing's provisioned by the time you send me the URL.
I got it. I should have it now in the moderator chat. Yeah.
Cool. Thank you. Now in process. All right. So back over to slideshow, and let's get out of this for a second. Hop on over to here. Don't need certificates on test consoles. That's just silly. Melvin, can you still see my Slack and everything? Please say no. Good stuff. Logging in here. So log in, go OCP console. And, Matt was pointing out that we build Operator Hub into the console itself. So if you look here under, your administrator side, okay, cool, this is 4.4 cluster. You've got operators and then Operator Hub right here. Super sweet. So I'm going to install an operator. If you've ever heard of serverless, you might have heard of Knative. So I would like to install the official OpenShift serverless operator. So let's do that real quick. On the main page, you search for Operator Hub, you get your OpenShift serverless operator. It tells you kind of the prerequisites here. There's a getting started guide. There's really only two, and it's great that this one actually tells you what they are. You need 2 namespaces. So let's go ahead and hit install, and it's going to whine at us because I don't have the namespaces created, I bet. But that's fine. The operator will install itself. Go in the wrong place. Good. And I'm blowing it right now, aren't I, Matt? It's okay, though. Use Chrome, it's the fastest. Installed. Okay, cool. All right, so let's go to installed operators here. All right, so we got our OpenShift serverless operator. It has succeeded in its installation, just like that, done. Before I could check to see if it actually failed, it was running. So what can you do with this operator? You click on the informational page, you can create a Knative serving instance and a Knative eventing instance. Well, we need both, right? So you can't have, Knative. You can use one or the other, sure, but you kind of want both if you're going to run them in your cluster. So what's the problem here is that it's going to tell me, and when I hit create on this YAML file, it's going to whine, mission webhook, blah, blah, blah. You need the Knative serving namespace in advance. So we don't even have to leave this interface here to do that. We will just create a project, Knative serving, done. We'll switch to that. Sadly, we'll go back to our installed operators. Where is this running, Matt? Is it in AWS, I'm assuming?
Yes.
Cool. All right, so now we hit create and things start firing. So what is going on here? So we're creating a Knative serving instance. Resources are getting spun up, essentially. As you can see here, there's a number of services, big maps, deployments all rolling out right now. And you'll get a full idea of what all is involved in an operator just by looking at the number of things that are in here. So many secrets, so many pods, so many deployments, so many config maps. This is the power of operators. You're baking in operational knowledge to your clusters and making it available to your users. Now, this is the administrator view. If we switch over to the developer view for this namespace, you will see that since all these resources, that there's a whole bunch of fun going on in here now. So this is actually all the different pods and deployments and services that have been spun up from that Knative eventing create instance type. So if you want to go to, say, look at the download CPU usage, you could totally do that. You could say, oh, we're getting a lot of bandwidth increase right now. What's going on? If this pod were to fail, you can try and scale it down. The operator will scale it back up. If, now it says 0, now it's scaling back to 1. The operator is declarative, like I mentioned before. See 1 pending. It will put the cluster or the instance that you have built with the operator back into the state you want it in immediately. Well, almost immediately. There you go, running. So yeah, now you can see that started basically the resources. Here's the pod, here's some routes. So if you want to hit the endpoint, you can. Privacy warning real quick. Directory listing, just went from nothing to Knative, boom, overnight, essentially. There I am downloading a, client for it. So yeah, that's like the kick the tires, light the fires version of that. If there's any questions, feel free to take them. Right now, we have scheduled a break. If everybody's cool with that, we'll take a 15-minute break. If there's a wide swath of people in chat that say no break, keep pushing forward, we will not take a break now. Push forward. But when we get back, Michael will be taking over. Let's say I have 8 after the hour. Matt, Mike, you want to give it 10 minutes? 15? Take your pick.
I'd go for 10, personally.
Okay.
I'm ready to rock.
So, you're ready to rock? Okay, so let's
I've been gearing up over here.
Let's do 18 after the hour, and we will, be here and ready to answer your questions. And we'll get started at 18 after. Thank you.
Yeah, and you may have already said this, Chris, but just since I joined a little late, next up we're going to dig into like the details of Ansible, and we're actually going to build an operator together using Ansible after we come back after the break.
Awesome.
So, yeah, see you then.
Thank you. All right, everybody. Michael, you there, buddy?
I'm ready to go.
You ready to go? You gonna take over slide sharing and everything?
I will.
Okay.
And let's see, I
Please.
see one question just came in from someone who just
Awesome.
joined. Welcome, and we're just going to
Could
dive
you
into my
share
favorite
the
part.
instructions? Perfect.
Yes. So we will do
So
that.
yeah. You're using 2 Katacoda modules, right?
Yep.
We have place for folks to access them, I think. Run up some extra ones off to the side somewhere, Matt, right? But if you're
I'm going to put the link in here right now.
Thank you, sir. I will pass these along to the folks playing along at home on the live streams. We'll have to provision these yourselves.
Hi.
You
Hey,
put those. Okay, there we go.
you guys got my screen okay?
Yes, sir.
Beautiful. Well, with that, let's plow forward, and I'll introduce myself here. So I'm Michael. I've actually just recently had my 8-year anniversary at Red Hat, about 4 weeks ago. It's been a wonderful 8 years, and been in the container space basically since Red Hat got involved in the container space. I was involved in some of the early discussions when Docker first became a word that everybody knew, but nobody knew what it was, and helped put together our first container registry and come up with a way that we could produce and especially make available container images to our customers and to our community. So gradually moved from those kind of responsibilities into Kubernetes as that came up, and worked on the operator SDK itself for a while, and was part of a small group of folks who basically built the Ansible features into the operator SDK. And very excited still about what that opens up in terms of possibilities, how easy it is to work with Ansible and Kubernetes, and how good of a fit it is. And so I'm just always eager for this kind of opportunity to share that with you folks and talk about how this can really make your lives easier in a lot of ways. And yeah, I'm a software engineer. I like tools that can make my life easier and give me an easy out. So hopefully this will be useful to you. And with that, we're going to dive into some details. We're going to look right now at how do we use Ansible to interact with Kubernetes. Then we're going to do an exercise. Then we're going to talk about how do we take that and make an operator using Ansible, and we'll do an exercise to do that as well. So, that, dive in. Oh yeah, I'm coming to you, by the way, from Raleigh, North Carolina. Normally I work out of our office. Our global headquarters is here, but of course I'm working from home. As everybody else. Well, the Ansible K8s module, let's interact with Kubernetes. So I'm sure you've already seen some examples of this so far, even in this workshop, but these, just by way of example, are Kubernetes object definitions. This is YAML definitions. On the left, we have a pod. Of course, a pod is how we run a container. And on the right, we've got a service. These are just arbitrary examples of Kubernetes object definitions. We could take this YAML, write it to a file, and run oc create-f, that file, or kubectl create-f, that file. And our client would create that resource in Kubernetes, right? These are the kind of resources that we live and die with in Kubernetes, that we're working with all the time. As we're deploying things, as we're adjusting configuration, as we're making changes to the cluster itself, this is what we're using. Now, how can we use the Ansible Kubernetes module to actually become our client for creating and applying those kind of definitions? And I'll pause here for just a moment quickly and say there's been quite the evolution over the last several years of Kubernetes support in Ansible. So if you've used Ansible for a while, and if you've used Kubernetes for more than, let's say, a year and a half or 2 years, there's a real good chance that you came across a prior incarnation of Kubernetes support in Ansible. There was a K8s raw module, and I feel like there's another one that the names have escaped me at this point, but suffice it to say, the current K8s module is light years beyond what we had in those early days. And so if you use those and had whatever kind of experience you may have had, suffice to say, you're going to be very pleasantly surprised by easy to use this K8s module is. It is fully dynamic, so it's based on the dynamic client. It's a relatively small amount of code. We originally started out by auto-generating this giant pile of code based on Swagger specs, which is a totally normal thing to do, but comes with advantages and disadvantages. Well, this K8s module is really nice to use. So here we are looking at some examples of config map definitions. On the left, we've just got a normal config map as you would interact with it in your everyday Kubernetes life. And on the right, we have that exact same YAML. You can see side by side is exactly the same, that stuff in red, except that on the right side, we are using Kubernetes to create that, or really apply that definition to a cluster. Now let's pick apart what's going on here. What we have here is what's called a task in Ansible. In Ansible, typically you're automating things as a series of tasks, just like any other kind of workflow you might automate, whether it's repairing your car or doing chores at your house. You're going to go through a procedure of tasks to accomplish some greater sort of project, right? So Ansible is the same way. We think of these individual tasks, we put them together in a linear fashion and come up with these broader workflows. Very much like programming, honestly. So here is an individual task. We gave it a name, create foo config map, and we're using the K8s module. And here's where Ansible has a very rich ecosystem of modules that do all kinds of things. Often you would start off in a classical use of Ansible by maybe installing some packages with yum or DNF or apt or your favorite package manager, and then configuring a firewall or who knows. Well, in our world, we're interacting with Kubernetes, so we're using the K8s module. And within that K8s module, we can provide a definition directly here in line. So that's what we're doing. We're inlining this YAML definition. And as you've probably caught on by now, I took the opportunity to just templatize this definition, the value of the color here I've templatized. So we're on the left, we're hard-coded. We have this hard-coded value of red. And on the right, we've templatized that. So if we were to run this Ansible task, that value will get rendered based on whatever variables are currently in Ansible at that time that it runs this task. And just like a programming language, there's different ways to load and calculate or derive values for variables like this based on whatever kind of logic you want or whatever data source you want. So that's a really powerful thing. But you can see already, you can take existing YAML that you have. You could take an existing Kubernetes manifest you have today and turn it into an Ansible task immediately just by inlining it here. We've got 3 lines of Ansible up at the top here, and then you can just put your manifest right there. So very simple way to get started. But we can do better than that. I'm sure you're already thinking, well, I don't want to manage even more indentation in my YAML. There's YAML inside YAML or whatever. We've got a solution for you. So this is the second way that you can use Ansible as your Kubernetes client, and this is my preferred way to do it. So here, again, we have a task. We're using the K8s module, but the definition we're providing, instead of inlining it down here, we're using this lookup feature of Ansible. And if you're an Ansible user, you've probably used the lookup feature in other domains, in other areas. But here, we're looking up a template, and we're giving a file name for the file name that we're expecting to find. And that's really it. We can put any Kubernetes YAML we want in that file, and this task will read it from disk. It will render whatever templatized options we've put into that template based on variables that's in memory at that time, and then apply that manifest to your cluster. So you could take a very complex, even collection of YAML files of Kubernetes manifest that you have right now, put them into a directory on your disk, and then use Kubernetes as your client to apply them, and immediately start templatizing them and taking advantage of Ansible's ability to templatize and to have logic in your templates, and so on and so forth. This is right away a nice declarative way that you can use Ansible to interact with Kubernetes. Now let's look at how Ansible organizes and structures its tasks. So we have this thing called a role. An Ansible role is a way of collecting related tasks and related Ansible code into one unit that can be packaged together and distributed together, maintained together. And you can think of a role like a role in a movie or on a TV show. You know, this person has a certain role and some other person has a different role. And in classic, traditional kind of Ansible use, you might have roles for your infrastructure like DNS server or web server or application server or firewall, rules or something like that. And you would basically do a mapping of, okay, I've got a group of machines and I have a set of roles, and I can say, these 10 machines, I want you to apply the web server role. And these 4 machines, I want you to apply the DNS role. And that's how roles have worked in the past. Well, here what we're going to do, we're going to use a role as a way to define an application deployment, a workload deployment on Kubernetes. So you could say if you wanted to deploy, let's say, WordPress on your Kubernetes cluster, we could make an Ansible role for WordPress that deploys WordPress on a Kubernetes cluster. That's our starting point. That's what we're learning how to do right now. And then our next step after that would be to take that role and turn it into an operator. But we'll get to that in a few minutes. Now here in this Ansible role, it's going to be scaffolded out for you. So the operator SDK will scaffold this whole directory structure out for you. But there's really only 2 pieces of this that you need to know about to get started and be actually very productive. This main.yaml in the tasks directory, that's just where you can start putting your tasks. Just like the ones we saw a few minutes ago, you can start putting one after the other tasks in that main.yaml file. Then in the templates directory, that's where you can start creating template files. So when you saw me a minute ago referencing a template file called foo.yaml, that would exist inside this templates directory. All these other directories you can get to know along the way, but if you just know about this one directory and this one YAML file, you can get an awful lot done with Ansible in your Kubernetes cluster. So I know we've talked a little bit about this already during this workshop, but why would you build these operators with Ansible? Well, many people already have experience with Ansible. You're already using Ansible in other parts of your infrastructure, and maybe you just haven't thought about it as a part of the cloud native tool set or part of the modern cloud management kind of set of tooling. But it absolutely is a wonderful tool in that collection. You might have some Ansible assets that you can reuse today. You might be deploying workloads using Ansible and be able to take advantage of those existing assets and convert that to a Kubernetes type of deployment or any number of other things. There is a big ecosystem of modules and other kind of features in Ansible that you can take advantage of. For example, so a space I've been working in recently, the last couple of years, is managing bare metal infrastructure to create Kubernetes clusters straight from bare metal. No virtualization layer, no other management tool involved, just self-managing Kubernetes native bare metal stuff, right? And one thing we've been leveraging and looking at heavily is Ansible, because we could use Ansible to say, for example, reconfigure networking equipment on the fly. Ansible already has a module that can interact with virtually any kind of networking equipment you might come across. And so you could easily use Ansible, bake it into a Kubernetes controller using Operator SDK, and use that to start dynamically reconfiguring your networking infrastructure for your cluster as you're going. You could interact with all kinds of other off-cluster resources like databases, file servers, other kinds of appliances, whatever you might have. There's a really rich ecosystem of stuff here that you can just immediately start plugging into your Kubernetes infrastructure. And of course, even if you're not experienced with Ansible, it's a very low barrier to entry, very easy to learn, and I really enjoy working with it. So in any case, let's just plow forward here. And it is time officially for an exercise. So we're all going to go to learn.openshift.com/training. I'm sure Matt already went over this with you, but that /training part of this URL is very important. So anytime you want in the future, you can come back to learn.openshift.com and go through these exercises. There's many other exercises available, all kinds of topics. But right now, for this workshop, we have provisioned dedicated infrastructure just for you to make sure there's enough infrastructure and enough capacity for everyone. So learn.openshift.com/training is the URL for you. And then you click through and you get to this Operator SDK. We'll be looking at this grid of 7 exercises. We are going to start with the Ansible Kubernetes modules, one right here in the middle. So just click on Start Scenario. And all you need here is your web browser. You don't need anything else installed on your machine. And we're just going to go ahead and click Start Scenario. And it's loaded up. In case you're getting a message here like hang tight while it's provisioning, usually it only takes maybe 30 seconds or something to get past. So what I'm going to do is go through this exercise live with you. Everybody has their own style. If you prefer to just plow through this kind of on your own, feel free to do that at your own pace. Otherwise, if you would rather follow along with me as I go through it and talk through it, that's fine too. Take your pick. But one way or another, we'll meet at the end. Okay, so we're going to, right now we've got this terminal here. By the way, this is a real, actual OpenShift cluster. You can see what we have in front of us here. Wow, 4.4.8. This is a pretty new release. We've got a 4.4 client, a 4.4 server, and we are ready to start doing these exercises. So, all right, we're going to start. We have a role already, an Ansible role that's called creatively example role. It's an Ansible role that's an example for you and I to work with right now. And we're going to start by looking at it. And let's see. I'm just going to, because I'm picky, make this livable. So we can do this in a civilized fashion. I'm going to use Vim and try to like do this kind of the old school way to just show you that no, there's no magic, there's no tricks up sleeves, nothing like that. But feel free to just click on these nice little links. So what you can do, you could just click this link when you're in the terminal, and it will replace the file with the modified one instead of you having to come in here and do that manually. I'm going to do it manually just kind of for fun. But feel free to take your pick on that. Okay. So here we've taken this empty main.yaml tasks file and we have put in here a task, one task. And what are we doing here? We have used the K8s module. We're just inlining a namespace. So what we expect this to do is to create a namespace. Okay, I think we can save that. Continue forward. Now we're going to learn about the defaults. So in this defaults file, we can, you guessed it, specify the defaults. So in case they aren't defined through some other means, you can say state present. Unless we specify otherwise, the state variable will be present. And so when this template gets rendered, state here will get replaced by the string present. Okay, so we've done that, and we're ready to actually run this. So here I'll show you an example of, you don't have to type this, you don't have to copy and paste it. Anytime you see this dark text, white on black, or white on like dark gray, you can just click on it, and it automatically goes to the terminal and gets executed. So now Ansible's running, gathering facts. These are not the beefiest or strongest, I guess, lab environments. So it takes a little bit of time, but here we got through it. Okay. So we just ran. So what just happened? We saw two tasks actually run here. So there's a task called gathering facts. That's just basically a default task that always runs anytime you're going to run an Ansible role. You're always going to see that. And that's just Ansible evaluating the state of the world before it gets started. And then the second task it ran, we recognized. That's our task that we just pasted into that task file. We see that OK equals 2, so that means 2 tasks ran and they were both OK. One task changed something, so that's interesting, and that's what we would expect. We said in our task we want this namespace to exist. We declared in advance that we want this namespace to exist, but it did not exist, so Ansible created it for us. In here we're already maybe seeing some parallels, where with Ansible, and this is how Ansible's always worked, and it's been doing this for a really long time, we use Ansible to say, Ansible, this is what I want, and I don't care what the current state of the world is, just bring the state of the world to this declared state that I'm asking for. And that's what Ansible just did. And in fact, we could even run this a second time. And it might go a little faster the second time. But what we're going to see here is that instead of changed equals 1, changed should be 0, unless somebody's messing with me in the background. But I don't think that's the case. So as soon as this is done running, we're going to click on this OC get projects and look for that namespace. Now, what is a project? So we see here 2 tasks ran OK, but 0 changes this time. So that's what we would expect. Now let's run OC get projects. Now a project is an OpenShift concept that sort of adds some features on top of namespaces to give a better concept of multi-tenancy and teams, and give like development teams their own space to do more advanced things. Suffice to say, for this purpose, a project is a namespace. So here we're finding, yes, that namespace did get created. It's here as we expected. So that's exciting. All right, let's continue on. And okay, now we're going to do something a little more advanced. We're going to actually deploy Nginx. That's kind of interesting. So we're going to start by copying the deployment definition, which is just here in our directory, our active working directory here. We're going to copy that into our templates directory in this role. And let's just take a look at this. So this is a scenario you may find yourself in. You may actually have this opportunity right now. This that we're looking at is just a totally normal deployment definition. Nothing Ansible about it. There's nothing OpenShift about it. It's just a normal Kubernetes simple deployment to deploy the Nginx container image. And let's see, it looks like on line 18 here, it's going to deploy 3 of them, right? So totally normal. We're just going to take this manifest that we could just OC create it or OC apply it, but we're not. We're going to use Ansible. So we are going to run this copy command, and here I'm going to just click and do the lazy option. We already looked at it and saw what's going on there. Now, let's see, we want to update our tasks file so that we reference it and utilize that template we just made. Again, I'm going to take the hard way and do this manually. Feel free to take the easy path and just click that link down there in the terminal. There we go. I think that looks about right. So, all right, what are we doing here? Again, we're using the K8s module. and we are providing a definition instead of inlining a definition. This time we're using that lookup feature that we talked about a few minutes ago. So we're going to look up that template by file name, and we just created that file. Well, we copied it into the templates directory, right? So that's where Ansible is going to look for it, and we are ready to go. Now it's time to run that playbook again. And what is a playbook, by the way? Well, a playbook, without going into any more detail than we need right now in this session, a playbook is a way to call multiple roles. Think of it like a play, like Shakespeare or something, where there are multiple roles that need to all get applied and organized in some way. So you're going to take these roles and apply them to these machines, and some other roles apply them to some other machines. A playbook is just a way to tell Ansible, run this role, then run some other role, and some other stuff. So it's our vehicle for running roles. Okay, we had 3 tasks run this time. That's what we expect. One of them is this new one, set Nginx deployment to present. We saw 3 OK and 1 change, all exactly what we would have expected, right? So let's run this OC get all, and we see that, yes, in fact, now there are 3 pods running. We have a deployment that exists. That's the thing we just created. And then, of course, there's the replica set that is a child resource of that deployment. So everything worked just as planned. Now let's continue on to step 3. Well, what else can we do? Let's modify this defaults file and do a little templatizing of our new template. We're going to go into that defaults file, main.yaml again. We're going to add a line here. We're going to set a default value here. Now, there are ways that you can pass in these variables to Ansible at runtime. So we could, for example, pass values on the command line. We could use Ansible to look up these values from some other source, and we'll see as we get into operators that we're going to use custom resource definitions to pass these values in later. But for right now, we're just going to take the easy path and use this defaults file. I think I spelled everything right. Okay. Find out in a moment. Okay, we've got to modify our template. Okay, so instead of a number, I'm going to replace that with that variable name. And now Ansible is going to render that using whatever value is currently set. And we set a default a moment ago of, what was it, 2. So that's what we expect to happen. So, seeing what's going to happen, right now, that deployment is set to replicas 3. We're about to run Ansible playbook, and that's going to change it to 2. So what I'm going to recommend is, after you click this, be ready to click the next one right away. All right, so we're running Ansible, and as soon as it's finished, I'm going to click this next one, the OC get pods, just so we can try to quickly see if we can catch one of those pods in terminating state. Because since there's 3 now, but we want 2, what we expect is that Ansible is going to, well, it's going to change the size, the value of replicas, and that controller, there we go. It's resizing the deployment, so it's deleting one of those pods, just as we would expect. If we run it again, okay, we're down to 2 pods. There you go. That is a real quick and basic intro to how you can use Ansible as basically just a Kubernetes client. And already I think you can see that it's pretty powerful. And what we're doing here is obviously very trivial because, well, this is a workshop and we're trying to just show you the concepts and enable you to do this yourself. But probably with your imagination, you can see how you would be able to put these tools together and make series of tasks and multiple roles that understand how to do much more advanced things with Kubernetes and be able to do them. We're not writing any Go code. We're not writing really any other kind of code. We're really just declaring in a very natural YAML kind of way what we want and running Ansible, and it gives us what we want at the end. So with that, congratulations, we completed this scenario, and we're going to go back and continue a few more slides before we then go make an operator. And I'll invite just Chris, Matt, if there are any questions that we should address at this point, feel free to jump in. I'm not looking at the chat. Otherwise, I'll plow forward.
Nothing that I see. There's a broken Katacoda out there, Matt, or OLM, if you see that. But yeah, we have a thanks, Matt. We have a poll that I just dropped in chat. If you don't mind taking that, we'd appreciate it. Or not a poll, a survey. And then I have a poll regarding the survey. So yeah, let's have a little fun with polls. But yeah, no. Go on, buddy.
Awesome. Well, let's look at how to make an operator, and then we're going to actually do it. Operators with Ansible. So of course, the operator SDK is what enables you to create operators. Easiest way. You can do it with, as Matt showed you, I think, earlier, you can do it with Go, you can do it with Ansible, you can do it with Helm. Right now, we're going to look at Ansible and how to do it with Ansible. So a quick refresher. So a custom resource definition. This is a way that you can add your own endpoint to the Kubernetes API, which is kind of amazing. I mean, how many other API services do you know that will enable you to just add your own arbitrary endpoints? And with something like a very simple definition, you get all this power out of it immediately to create, all the normal create, read, update, delete kind of stuff. But the eventing, where you can watch that resource, and all kinds of other advanced features, it's really kind of amazing. So a custom resource definition is a way that you can add your own endpoint to the Kubernetes API service. So in this case, there's a memcached resource. And what we're going to do is a one-to-one mapping of a custom resource definition is mapped to an Ansible role. So we can make an Ansible role called memcached that receives that CRD as input. And in the spec, you see we've got size 3 here, for example. What we're going to end up doing is using this spec to collect input that gets passed, that gets passed into Ansible at runtime. So here's the operator pattern again that we saw before, right? So the Kubernetes API is storing custom resources. It's doing all the data work for us and emitting events as those resources change. We have this controller here that watches events. That controller says, okay, API service, anytime that memcached resource changes or gets created or one gets deleted, let me know. And it sits there and watches. And every time one of those events comes in, it runs some kind of reconcile code. And that reconcile code, its job is to evaluate, okay, what is this resource declaring? What has been specified in the spec of that resource as the desired state? Compare that to the real world state, and then change the real world to match what's been specified in the spec. And in our case, for an operator, what that means is the spec has specified I want an application deployed, like memcached, and the result is that that application should get deployed. Now with Ansible, let's see how Ansible fits into the middle of this here. So we have this binary, and it actually is the operator SDK binary. That's sort of an implementation detail. So we created a generic operator using operator SDK written in Go that calls Ansible. And its reconcile logic, instead of having a bunch of reconcile logic written in Go, instead it generically calls out to Ansible and passes the custom resource data into Ansible as its input. So at the end, it's actually pretty simple and elegant pattern. There's a lot of details that had to be sorted out in there logistically, but that's really what's happening. We have this binary that sits here and watches for those events, and when it gets an event, it just runs Ansible. And now how does it know what role to run? Well, we've got this watch file. We'll see an example of it in a moment. This watch file, yet another YAML file. Everything's YAML in this world. This watch file really just says, okay, for a particular group version kind, so let's say like the memcached CRD that we just saw a moment ago, when you see an event for that type, for that group version kind, run this Ansible role. And you can put as many of those pairings as you want into that watch file. And that's all that this needs. You just put some roles into your operator container image and tell the operator about them in this watch file. Kind of it. Getting a little more advanced, there's some pretty cool stuff actually going on here that we could spend probably the rest of the session on, but we won't. But suffice to say, there is a reverse proxy going on here, which is kind of neat. So when the controller runs Ansible, we're running it using this project, it's a little sub-project called Ansible Runner that was formerly part of Ansible Tower. Well, it still is part of Ansible Tower, but we were the first ones to borrow it outside of Ansible Tower and use it. It's really just a programmatic vehicle for running Ansible. You saw a few minutes ago in this last exercise that we were running Ansible on the terminal as humans, seeing output that is very human-oriented and not necessarily programmatically oriented. So Ansible Runner is a vehicle for running Ansible in a programmatic way. And when we run it, rather than have it talk directly to the Kubernetes API, we put this reverse proxy in front of it. And this does a few things for us. One is it enables us to run a cache. And that's a very important concept that I'll just say as a very strong suggestion. If you are creating controllers for Kubernetes, whether it's in Go or Python or Java or Ansible or anything else, it's very important that you utilize the caching features that the Kubernetes API encourages you to. Because if every controller running in a cluster was constantly hitting the Kubernetes API every time it needed to list resources or something like that, it could easily just destroy that poor Kubernetes API service. A normal Kubernetes cluster has tons of controllers running in it. So it's very important that each controller maintain its own cache of whatever resources it cares about. And this reverse proxy enables us to do that automatically for you, to have this long-lived cache that every time the Ansible code tries to interact with the API, like to get resources or list resources, it's actually interacting with that cache. Then we can also do things like, if you're familiar with owner references, we automatically put owner references onto every resource that your Ansible code creates. There's some features we do with finalizers optionally that you can take advantage of, and a bunch of other stuff. So in any case, it's just worth knowing that there is this reverse proxy here. The Ansible code has no idea, doesn't really care, doesn't matter to your Ansible code, but it does give us an opportunity to do some more advanced things. Okay, here's that example I promised you of a watches file, and it really is, you can see we've got a group, version, and kind, and here we're mapping it to a playbook. So you can either specify a playbook or a role, and here this is just the full path on disk. Oops, clicking on slides is a bad idea. This is just a full path on disk inside your container image to where that playbook lives. Or if we specified a role, then again, it would be the full path on disk inside your container image to where that role lives. That's really it. You could put as many of these entries in here as you want. Now, there are additional features that we probably won't get into during this session, such as finalizers and some other things that you can also specify here to tell your Ansible operator, when you're dealing with this memcached resource, maybe add these more advanced features or behaviors or whatever it may be. There's other stuff, you can go read the documentation for that. But these are the basics. This is what we need to get off the ground. And good news is that this file gets auto-generated for you, just like everything else you need. So by default, it's just going to be there, ready to go, and you can just use it. Okay. We probably saw this earlier in the session, but just as a reminder, Ansible, fully capable way of creating your operators. Ansible is a very rich tool that, like I said, is very feature rich in terms of its ability to interact with all kinds of other resources beyond just Kubernetes, but also very rich in terms of the kind of logic you can generate. I've done various implementations, and my colleagues have done various implementations of quite advanced controllers, all in pure Ansible, and it's a very nice experience. So I recommend anybody who's going to get started with a controller, try it in Ansible first. And it's just so much quicker to get off the ground and get things going that way. Usually people find that the momentum they have from getting started with Ansible, they just love it and they keep running with it. But Go is also a very good option, and I enjoy doing it in Go as well. In Helm, of course, Helm is a very good option if you have Helm charts already that you want to utilize. You want to be able to quickly plug into the operator ecosystem. But the Helm is a very good tool, very good at what it does, but it's not really designed for this like rich active management kind of stuff that you can do with a programming language. Okay, let's look just quickly at this custom resource spec and the status. So in the spec of your custom resource, so let's say this is that memcached resource, right? You can put as many key value pairs as you want, and whatever you put here as key value pairs gets passed into Ansible at runtime, and those keys are available as variables inside Ansible. So when you're writing your templates, any variable you put in a template gets rendered based on these keys right here, which I think is pretty phenomenal. I mean, there's all this plumbing in between, of course, but we've made it that easy for you to go from just create a custom resource with the Kubernetes API and directly provide these key value pairs as input to your Ansible code. Very simple. And then the status. The Ansible operator will automatically generate a generic status for you that shows some basic things about what happened. But if you want to create your own status that has more specific things about your workload or what your code is doing, you can absolutely do that. There's a separate module for that. We're not going to get into that during this session, but that's absolutely available for you to do. And now let's look at what do you have to provide versus what is provided for you. All the stuff on the bottom here inside the gray box, all that is provided for you in this base image that we provide. So the binaries in there, Ansible itself, all the Python interpreter and libraries are there, Ansible runners in there, everything, all that stuff is taken care of in that base image. The only things you end up adding on top are that watches file and one or more Ansible roles, and that's it. So it's a very nice, think about maintainability for just a moment. Like, I write a lot of Go code. I like writing Go code, and I'm a programmer. I like programming. What can I say? But rather than have this like giant project full of source files and all kinds of other assets and your Go module support and dependency resolution, all this kind of stuff. Look at how simple this structure is. Like, this is really all you have to provide here is just that one or more Ansible roles and this watches file that just basically ties them together to a resource. So when you think about who's going to be maintaining your operators or your controllers, who's going to be creating them inside your organization, if you don't have like a software team to throw at an operator project, you can get a lot done with a very small amount of assets here to maintain, and this is much more approachable and maintainable by, in my opinion, a small set of people, or even an individual, depending on what kind of size your organization is. So that's a factor that is important to a lot of people in determining or thinking about, do I want to use Ansible to create an operator or a controller? Okay. Operators CK new is the command we're going to run in just a minute to create our own operator. Everything is scaffolded out for us. And here, the important part here is we're specifying the type of this operator is going to be Ansible. Operators CK, of course, is the tool that we use to both create operators from their initial scaffolding, and then do some maintenance kind of things as you go through their life cycle, packaging, and even participates in some cases in the building of your operator. All right, now it's the moment you've all been waiting for. Our next exercise. We are going to make an operator. So I'm going to click on this More Scenarios button to get back where we were. So now we're going to go to Ansible Operator Overview, Start Scenario, Ansible Operator Overview. Just like the last one, I'm going to go through this one. You can follow along with me if you prefer. Go through it on your own if you prefer. We'll meet at the end in just a little bit. So I'll go ahead and click Start Scenario. Now, I have good news. There are 8 steps in this exercise, but the first, let's say 4.5, are really just reading and learning material, and it's all topics that we've already gone over, that you've already learned and are now familiar with. So we are just going to fast forward all the way to step 5. You can just click this little arrow here and click through these steps all the way to step 5, create a new operator, scroll down till you see running operator SDK new, and that's where we begin our task tonight. All right, we're going to go and run this operator SDK new, and all these files just got created. Let's take a look. We're going to run this tree command. I love tree. If you're not a tree user, I recommend it. All right, tree memcached operator. So let's look at what we got. All right, we have a build directory that got created for us. So it has a Docker file. Now, this is the Docker file for the operator, right? And some other assets related to testing. Now we have this deploy directory. This has assets related to deploying our operator. So we have RBAC assets, service count, role binding. The operator itself, there's a deployment definition inside this operator.yaml file that will actually run your operator itself in a cluster. We have the CRDs, of course, very important part of this. So it automatically created a memcached custom resource definition for us, and even created an example custom resource that we can use just for testing and demo purposes and that sort of thing. Molecule. Now this is another topic that is very neat stuff, but we're not going to get into it during this session. But Molecule is, suffice to say, a testing tool for Ansible. It's very popular in the Ansible world and turns out to be very useful for testing controllers, even controllers that were made with other things besides Ansible, as it turns out. But I'll leave that as homework to you to look up how to use Molecule. And then finally, we have the roles directory. We have one role that's been auto-created for us called memcached, and it has those same pieces that you already recognize, right? We have this tasks main.yaml file, remember? We have a templates directory that's empty, just waiting for us to put a template in it. We have that defaults directory with its YAML file. We remember using that. And a couple other things that we'll get to know at some point along your journey. And finally, of course, that watches file, auto-generated for you. It's already got the values that that you need to use this role. So everything you need to get started. In fact, I mean, we could already run this operator as it is. Now, of course, it won't do anything. There's nothing in this tasks file. It's empty. But this is actually ready to run. Okay. Well, with that, let's get to work on it. So we're going to change directories in the memcached operator. And this is just giving us a tour that we already took of the scaffold. So let's continue on to step 6. Time to customize our operator logic. So just like we did in the previous exercise, we are going to add one or more tasks into this role so that the role actually does something. And at reconcile time, our Ansible operator is going to run this role. Now, rather than us sit here and start typing away or copying and pasting things around to start filling out a role or putting tasks into our role, one of my colleagues, Dylan, has helpfully created a role for us and put it on Ansible Galaxy where we can easily retrieve it. So Ansible Galaxy is this command line tool that accesses this global repository called Ansible Galaxy. It's sort of like Puppet Forge or the Python package index or the Node.js thing or whatever Java does. I'm not a Java developer. It is a global place where people can share their roles and make them available for download and reuse. So we're going to run this command, and it's going to automatically fetch that role from GitHub, and it just installed it for us in that roles directory. Let's see what we got. All right, so we have two directories here. We've got the memcached one, which is the auto-generated one we got up here, right? And now we have this new one from Dylan. Thank you to Dylan. So we are just going to go ahead and rm-rf, that old one we don't need anymore, and then take a closer look at what we got from Dylan. So a very similar structure again. Now he's not using a templates directory at all, which is an interesting choice. He decided to just inline all of his YAML right in the main.yaml tasks file. We could even take a quick peek at that. All right, Dylan, tasks. So what we have here is just a normal deployment definition that's inlined into this K8s task, right? Or we're using the K8s module for this task. We inline the definition, and we're just creating a deployment. So it's going to run this memcached container image. We're exposing a port. Replicas we've templatized here, so that's interesting. Already we can see we're going to utilize that. And name and namespace here are kind of interesting. So meta.name is the name of your custom resource. So when we create a custom resource in a couple minutes, the name of that custom resource is going to be available inside Ansible as meta.name. And then likewise, the namespace will be meta.namespace. This pattern you see here is very common, where we're going to create this deployment we're going to generate its name as a derivative of our custom resource's name. And of course, we're going to create it in the same namespace as the custom resource that was created. Okay, that's probably enough of looking at that. Role variables. So if we go look in the defaults file, we've got a size of 1. See that here? So we saw that already in our template, size is a variable. And sorry, I'm a Vim snob. I can at least feel like we can live like civilized people. Ah, look at that. We've got line numbers and everything. Okay. All right, we already looked at that, so let's just keep going to the correcting the watches file. So because we changed the file path on disk where our role lives, it's now this dymurray.memcached whatever. We need to modify the watches file so that it has the correct path. To do that again, you can take the easy way and just click that link down there. But I'm going to do it the hard way just because that looks correct. We're good to go. All right. That's it. I think we're ready. So we're going to click continue. So at this point, Kubernetes is running, but it has no idea about this new custom resource definition. So we're going to go ahead and create it right now. In fact, let's just do this. OC get, here it is. Okay, we got a whole bunch of stuff. Nothing in an example namespace. Let's go ahead and create that and try this again. Okay, so our CRD exists. And I mean, again, I'll just say, like, every time I do this, I marvel at the fact that it's that easy to add an endpoint to this very rich API system. It's kind of amazing. But anyway, that's done. Now, this API service knows about that resource and can handle requests for it. We can create them, delete them, list them, and watch events for them. Okay, let's talk about running this operator. There's two ways you can run your operator. One is the normal production way, which would be to be a pod inside your Kubernetes cluster. That's how you're going to do it in a for real scenario. So what we would do is run a build command that would package up this role we just made in the watch.yaml file, put it on top of the Ansible operator base container image, and create this container image that you would run inside your cluster, and that's your long-lived operator that would be watching the API service and doing all the operator stuff. The second way to run your operator is like the developer mode, which is to run it locally. So when I'm developing operators, I'm running them on my laptop. I don't want to wait. It takes time to like build a container image, and you got to push it to some repo or some registry. Then you got to tell your cluster to restart that pod or create a new pod and get the new image. You got to wait for all that stuff to happen. I don't want to wait for all that stuff to happen just to find out if my typo fix, fixed the stack trace, whatever problem I was encountering. I want to be able to rapidly iterate, right? That's what all developers want. So this second way, we can locally run the operator. That's what we're going to do right now. We can easily run it in the foreground in our terminal, immediately see feedback from it, Control-C out of it, change stuff, run it again, and rinse and repeat. So those are the two ways. We're gonna show you the developer way right now because it's a little more interesting. Okay, so we're gonna copy some files here. Now, to quickly explain this, you may recall in our watches.yaml file, I'll just cat it. Our operator is going to look for a role at this path. Now, that didn't work well. Now that doesn't exist. That doesn't exist here on my local machine. That would only exist inside the container image we were going to build. Since I want to run the operator on my local machine right now, we're going to copy that role into that same location so that when Ansible runs locally in our terminal here, that it's going to be able to find that role where it expects it to be. Okay. Now, we're ready to run this thing. So we're going to create a new namespace called tutorial, and we're going to run this operator CK run command, -- local. We're going to tell it the namespace we want you to watch is called tutorial. It's the one we just created. Okay. And that all looks like the output we'd expect, and our operator is running now. We have an operator up and running. Normal kinds of things are happening. Metric server, leader election, it skipped it because it's not running in the cluster. Started the controller, this is the Go-based controller. Started workers, okay, everything's running. And now what we're going to need to do is open a second terminal window. So that's what this is telling us here. So come up here to the plus sign, click on that big plus, and you can click on Open New Terminal here. An extra interactive bash terminal. And now we can go back and forth. Our original terminal is here, terminal 2 is over here. So okay, let's get in the right directory. And we are ready to create that sample custom resource. So let's look at it real quick. Boy, right? Our CRD. Here we are. Okay, here's our example resource that just got scaffolded out for us. So there's a memcached resource. By default, it has just the size parameter 3. I mean, you can just totally blow this away and put whatever stuff you want that's going to be meaningful to your operator when you're writing an operator. But for us right now, we have this size of 3, and that's actually appropriate. So we're going to go ahead and create this thing. We're going to OC create-f that file. Okay, that resource got created. Let's come over here and Ansible's running. So we're getting the standard output here. And it takes a little time. Again, because these lab environments are intended for lab and workshop kind of use, and not the fastest. But in normal production, this is pretty quick. Okay, so we ran some stuff. Stuff's continuing to run. Go to terminal 2 and see what's going on. So just like it says here, run oc get deployments. And okay, we see we have a deployment, and there are 3 pods already up and running. And look at those. Okay, so it's just that simple. We already, now of course it's a very simple example where we're just rendering a template and it's creating these resources, but think about what we just did. Like, you can go from having a Kubernetes manifest file that defines how to deploy, you could put a deployment in there, services, pod disruption budgets, config maps, secrets, like all the kind of normal artifacts that you would have for deploying advanced workloads on your cluster. You can take all that stuff together, and in just a few minutes, run operator.ck new to create yourself a new Ansible operator like this, put your templates into that role, and immediately start taking advantage of this whole operator ecosystem, this whole pattern where we now have a custom resource that is our interface to running that Ansible code. And this is what is really making this now Kubernetes native. People say those words a lot and they mean different things to different people, but here, Kubernetes native really is getting at the fact that we're using the Kubernetes API itself to deploy and manage workloads. And the implementation of that is very simple Ansible code. How cool is that? Okay, let's continue. So let's see what happens when we change the size of, that didn't work very well, of that resource. So we're going to edit this thing again. You can do it the hard way like me with Vim or whatever, or you can just click that easy link. I'm just going to change to 4. And okay, what are we going to expect to happen when we save this? What I expect to happen is it's going to apply this to the Kubernetes API. The API service is going to generate an event to say, hey, this resource changed. The operator that's running over here in this terminal, it's going to receive that event. And in response to that event, it's going to go look in the watches file, find the role to run, and then run Ansible with that role. And then the output of that is that it's going to apply that template that we had, rendering it with the size of 4, and we should see ultimately an additional pod get created. That is still just 3. Watch this for moments. Again, Ansible takes a little bit of time for this controller to run. A quick peek. It did not run. Did not do anything yet. But patience is key. Oh, I skipped a critical step, didn't I? I did not apply that. Okay. That helps. Okay, Ansible's running. And we're waiting. There we are. Okay, finally it caught up to us. We asked for 4 replicas. There were only 3. So it applied that 4th one and ended up creating a pod. Again, this is a very trivial example, but you can see how you could do much more advanced things potentially. Have all kinds of advanced logic as is appropriate and necessary to the workloads you're trying to deploy on your Kubernetes clusters. Everything you've seen here, totally generic to any Kubernetes cluster. This is not OpenShift specific in any way. So we definitely encourage you to use this wherever you can. And the remainder of this is just a little bit of cleanup. So we can exit out of that. But, this is a throwaway environment anyway, so you're not under any obligation to clean up. We deleted the namespace, so that's all. Everything's gone. You hit continue, and congratulations. We made it to the end. So those are those exercises. There are, again, some additional exercises that you can come back to in the future. These environments, this link that you're at right now is going to expire at some point in the near future after we finish this session. But you can go to just learn.openshift.com anytime you want. No authentication, no account required, totally anonymous. You can be anybody you want to be. You can just go there and totally for free find these same exercises and do them on your own time. Share them with your friends and colleagues. And in particular, you might look at this. Where's the McRouter one? It's not here, is it?
No, I think the McRouter one's on the main site. We didn't spin it up for this because we didn't have it as part of the workshop.
Cool. So you can come to this main one anytime you want and go to building operators. These are all really good ones, but here's we call it the McRouter because we're silly, but the MC router. It's another nice example of showing you how to make a slightly more interesting operator using Ansible. But that is that, and Chris, I'll turn it back over to you.
Yeah, and folks, thank you for being with us today, and we have the survey available for you to fill out. Chat, please grab that link. In the time since I left doing my demo and coming back just now, I upgraded the cluster that I asked for to bail me out, that Matt luckily bailed me out with, but I've upgraded that cluster from 4.4.8, the default that you had, to 4.4.11. So yeah, you can tell that operators, doing things in the background for you can actually make managing your clusters a lot easier, as well as your applications. So the fact that I can upgrade a cluster in the time it takes to do 2 modules on Katacoda, I think is pretty amazing. That is the power of operators right there in itself. So without further ado, thank you all so much for attending. We hope that you have a wonderful Red Hat resummiting, whatever we're calling this, the Red Hat Summit July event. And if you're here tomorrow, we look forward to seeing you again then.
Chris, can I ask you a quick question?
Yeah, sure, buddy.
Have you shown us the shirt that you're wearing?
Yes, I did show it off.
Awesome.
I made sure.
The
logo slide made it into the slides, so everybody got to see that. So yeah, this is the operable, everybody. If I was doing this in front of a live studio audience, I would be wearing this as well. So yeah, I have 3 of these, so I'll be wearing another one tomorrow.
Nice. And in normal circumstances, when we could get together in person and do these kind of workshops, we have stickers sometimes. In fact, there's some in my laptop bag still, just in case, even though I haven't seen another tech person in months. I'm ready. So if you see us in the future at some time in the Red Hat booth at a conference or run into us otherwise, feel free to stop us and say, hey, I took your workshop. Do you have a sticker? And we've got a sticker we'll hook you up.
I may not have a shirt on me that fits you, but yeah, definitely have a sticker available for you in the future event where we're all at. So again, thank you for joining us today. Thank you, Michael, for wrapping us up. Appreciate that. And we'll see you all soon out there. Stay safe.
Bye, everyone.